Now let's talk about ospf. You'll recall that ospf is a link state routing protocol. This means that unlike distance vector routing protocols that send their entire routing tables, link state routing protocols like ospf send triggered updates or changed base updates, and they only send information about the changes. One of the advantages to ospf is the fact that ospf is an open standard. This means that any vendor's routers can use ospf, unlike IGRP or EIGRP, which are Cisco proprietary protocols. Let's take a look at how ospf works. ospf consists of areas and autonomous systems. This design makes it possible for us to minimize routing update traffic in any given area. What happens with ospf areas is that a routing update or a change or a topology change can take place in one area without updates needing to propagate into the other areas. Area 0 is considered or called the backbone area for ospf. All other areas have to connect to Area 0 in order for communication to take place. This provides a hierarchical approach to the ospf routing updates. This hierarchical approach to ospf also provides us with a way of simplifying our subnetting areas so that we might subnet the network area here, and then we would break out our subnets into each one of the different areas and then do our variable length subnetting into each of the areas as we get from general to specific. ospf also consists of different names for the different routers. Each one of the names represents a different function for each different type of router depending on where that router resides in the ospf network. For instance, you have backbone routers. Backbone routers are routers that have one or more interfaces in the backbone area, in Area 0. Then you also have internal routers. Internal routers are any routers that have all of their interfaces in one area. For instance, this router right here would be considered an internal router and a backbone router. It's internal because all of its interfaces are in Area 0, and it's a backbone router because it has one or more interfaces in Area 0. Then you have area border routers. Area border routers are any routers that have one interface in one area and another interface in any other area. This same router could also have an interface in a third area here, and it would still be considered an area border router. And then you have ASBRs, Autonomous System Boundary Routers. These are routers that have one or more interfaces going to another autonomous system. For instance, this other autonomous system might be running a different routing protocol such as EIGRP. If this router is running EIGRP on this particular interface, that makes this router an autonomous system boundary router, indicating that it has one or more of its interfaces in the ospf autonomous system here, and then one or more interfaces in another autonomous system. So in summary, ospf is a link state routing protocol, indicating that it sends changed-based or triggered updates, and it only sends those changes that have taken place. It does this with what's called link state advertisements, LSA packets, that send the changes that have occurred. ospf also is designed with different areas, Area 0 being the backbone area, and all other areas being connected to Area 0 in order for routing to take place. The different areas provide a design that minimizes routing table updates.